Eratosthenes by Max de Villa. A long time ago in 276 BC, in a civilization far, far away, there was a brilliant man named Eratosthenes. You can see his work everywhere you go, whether it be the lines of longitude and latitude on a map, or one of his historic books in a library. However, these aren't his only accomplishments. He also excelled in subjects beyond mathematics, including science and geography. But one accomplishment was far more influential than the rest. He was the first man to come up with an answer to the circumference of the Earth. He came to a conclusion of 39,690 kilometers, and he was only off by 1.6%. Not bad for a man who lived over 2,000 years ago. He got his answers by using the sun's rays and the angles that the Earth creates. Here's an example. He also reinforced the theory of prime numbers. He created the sieve of Eratosthenes. This was a way to find all prime numbers from 0 to 100. Here's a YouTube video explaining the sieve of Eratosthenes from Ron Barrow.
This time we're going to use a technique called the sieve of Eratosthenes to find out all the prime numbers in between 1 and 100. So let's start the process. First of all, 1 is not a prime number, so get rid of it. 2 is, because it's divisible by itself and 1 only. But all the other multiples of 2, in other words all the other even numbers, can't be prime, so let's get rid of those as well. The next number 3, well, it's not divisible by 2, so it must be a prime number itself. But let's have a look at the multiples of 3. They're not prime numbers, and so we zap them. 5 is the next number, and it must be prime because it's not divisible by anything smaller than itself except 1. Get rid of all the other multiples of 5 though. 7 is a prime number because it's not divisible by anything smaller than itself except 1. Let's look at all the other multiples of 7 in the list and let's get rid of them. Now we have to stop and think. Think about the numbers on the list which haven't yet been knocked out. If they are divisible by a prime number which is larger than 10, then they must also be divisible by a prime number which is smaller than 10, because 10 tens are 100, and you can't have numbers divisible by 2 prime numbers which are both larger than 10. So it follows that every other number on the list is prime, because we've got rid of all the numbers which are divisible by 2, 3, 5 and 7. So all of the numbers which haven't been taken off the list at that stage must also be prime numbers. And we've done it. We've found out a list of all the prime numbers between 1 and 100, and there they are in blue. This technique is called the sieve of Eratosthenes because the ancient Greek mathematician Eratosthenes used this technique. Why is it called a sieve? Well, basically, if you get rid of all the numbers in the list which are not prime numbers, just like letting them fall through the holes of a sieve, then what you're left with in the sieve is just the prime numbers themselves. That's why it's called the sieve of Eratosthenes.